I'm Dr. Tom Scott. I'm Director of the Interface Analysis Centre, which is a surface science and materials analysis facility within the Faculty of Science. The Interface Analysis Centre is a multidisciplinary hub for research from across the university for anyone who's doing physical sciences, whether that's working on teeth to working on nuclear fuels. We do it all at the IAC, and we collaborate with all of the other departments within the university to solve scientific materials problems. We're very lucky in that we've got a wide array of multi-million pound analytical equipment that we have at our disposal. Generically for materials science, in order to find out about your material or the material surface that you're interested in, we're always firing something at that surface. In some cases it may be electrons, in other cases it may be ions or even X-rays. So we're looking at measuring the response of the material to tell us what that material is made of in terms of the elements which are present, and also in some cases the way those elements are bound together to make compounds. One of our leading techniques is we have a dual beam system, which is a combined secondary electron microscope and focused ion beam system, and that allows us to perform nanosurgery. Recently we've had a project with the School of Biology where we've been working with insect specialists to try and understand better how insects hear. So we've been using the focused ion beam system that's in the dual beam to section the ear membrane on Indian tree crickets to determine what its structure is. This has never been done before because other techniques have had the wrong scale length capability. But the dual beam, with its nanometer scale length measurement, we can very, very accurately cut these membranes up and get new insights into insect hearing issues that have never been seen before. A key aspect of what we do is working with industry. For example, we do a lot in the civil nuclear sector. We have students who are specifically looking at the ageing of stainless steels in reactor conditions to understand how and why their properties change as a function of time, and whether that change in properties will have a significant impact on the safe running of the UK's nuclear reactors in the future. One technique that we use on a regular basis to do that is a technique called electron backscatter diffraction, where we fire a focus beam of electrons at the surface, and the surface is tilted to 70 degrees, and we look at the coherent scatter of diffracted electrons out from that point that we've hit. And by looking at the way those electrons are diffracted, we can tell the structure of the material we've hit, as long as it's crystalline. So for example, if we're looking at stainless steels for a company like EDF, then we're looking at determining the content of austenite versus ferrite. And it's a very useful technique which produces very visual data that are easy to interpret. The whole point of having the Interface Analysis Centre at the University of Bristol is to provide a multidisciplinary hub for materials science. And we work with lots of different departments because we are that hub. We work with the biologists, the chemists, the physicists, the earth scientists, and also the dentists. Because we have this amazing array of analytical equipment, it's enticing not just to researchers within the university, but also to researchers in industry. And that's why we have such successful collaborations, both within the university and externally.